When I remove the compound and I'm getting ready to put it back on, I like to swing these holes so that they're right in a line here, and that just makes it a little easier to visually line them up when you put the compound on. Well, it's not visually, and that's the problem, is you can't see them. So by having a good idea in advance where they are, it makes it easier to for the bolts to find their way into the corresponding threads there. So I'm going to swing this around until it reads about 30 on the protractor, and I hope that will be a good angle at which to do this adjustment. And then I'm going to tighten that down. I want to make sure that's pretty snug. You don't want to tighten it so tight that you strip the threads and the screws, but you do want it pretty tight because you don't want any looseness there that would show up as you might confuse for looseness in the gibs. So now we've got that screwed down snugly. We'll go ahead and bring this in. If you keep a little pressure here where the tool post normally is, that helps it go in a little more smoothly. So I want the upper part of the compound more or less centered, or at least these 3 screws here centered over the lower part, because I want to make sure that each of these 3 adjusting screws is actually over the metal and not hanging out over the edge. If it were hanging out over the edge and I tighten the gib strip could actually kind of bend around in an arc, which would prevent it from moving forward when we go to move the compound in or out. So now, having set that in the center, I'm going to loosen each of these in turn. I'm going to snug it up. I'm going to back it off a 1/4 turn just to establish my initial setting. So it doesn't really matter too much which order you do it in, but I like to start with the middle first and then do the other 2. Sometimes these little lock nuts can be awkward to manipulate, but loosen it up, back off a 1/4 turn, tighten it up. Same thing down here. We're going to loosen it up, snug it up, back off a 1/4 turn, and then we'll tighten up our lock nut here. Had a lot of play in that one, or a lot of looseness there. There we go. Let's see how it feels. Well, it's already really tight, too tight. So 1/4 turn wasn't really enough. And I like to start with it kind of loose. So I'm going to back it off, each one of these off another 1/4 turn, just to establish my starting point. So loosen the lock nut and just back it off a 1/4 turn from where it is now, until I hopefully get to a point. Well, it's still pretty snug. Now there's another possibility here, and I didn't plan to get into it in this video. I was going to save it for a later video, but there's another factor that can have a big effect, and that is the alignment of the lead screw. Since we're experiencing this, I'm going to go ahead and talk about it now. Sometimes the lead screw is not ideally lined up, and there is an adjustment you can make to correct that, and I'm going to go ahead and do that now because I think that's where my problem is. I obviously have quite a lot of play in here. I'm still feeling drag, so I know the drag's not coming from the gib strip, and really the only other place it can be coming from is the lead screw itself, where it engages with the thread here. And what I suspect is wrong is I had this disassembled earlier when I was doing some more advanced procedures, and when I put it back together I didn't bother to carefully line up the lead screw, and so I'm pretty sure the lead screw is a little bit out of line, and that's what's causing the drag. So I'm going to go ahead and fix that. And what we need to do now is first remove this screw here, and depending on how old your lathe is and where you bought it, maybe which vendor you bought it from, there are a couple of different variations of types of screws here. I've seen some that have Phillips head screws. I've seen most of them, the older ones, had a socket head cap screw there, and the more recent ones, like this one, have a sort of a round-headed screw. And of those 3 types, I think the round-headed screw is the one that's best. So if you have one of the other types, you might want to consider replacing it. And the reason is the round-headed screw has much less of a tendency, and particularly I think on the cross slide, to sort of gouge the edge of your finger when you're turning it. On the compound, unless you're cutting a bevel cut of some sort, you typically aren't turning this thing fast enough that it becomes an issue. But down here on the cross slide, you can sort of pound your finger on that thing. So the round head screw just makes it a little bit more finger friendly. You got to be real careful when you start to disassemble this that you don't lose any of the parts. So keep your hand here right around that, because there is a lock washer under here and you don't want to lose either the screw or the lock washer. And when I'm doing these types of jobs, I like to put my parts in a little plastic baggie here so I can so they don't drop off on the floor, and also I can keep related parts for an assembly together. This just slides off of here, and on this particular machine it slides off pretty easily. But a lot of the machines I've worked on over the years, this thing can be pretty tight. You may have to take two flat-bladed screwdrivers, sort of wedge them behind here and pry this thing off gently. But you want to be careful not to gouge up the surface of your collar here. So you may want to stick a little bit of cardboard or a thin piece of leather or something behind that to protect that surface if you do need to use the screwdrivers. Alright, so we'll set that aside, and then there's this washer here, and it's typically harder to get off, and this one actually is pretty difficult. So I'm going to try to get it off by grasping this inner ring here, or not the inner ring, but this calibrated ring, and using that to give me a little extra leverage to pull it out. And that's not working. So the problem with this washer is it's on here fairly tightly, but there's very little space behind here, not enough space really to get a screwdriver or anything behind it. And you could take a pair of vice grips or gas pipe pliers or something like that, but you'd very likely gouge up this surface, which I don't want to do. So my solution to that is I'm going to take my 3-jaw chuck and adjust it to fit over that. Okay, so I'm going to just hold this, back the jaws off just a little bit. I had them already pretty close, so I'm just going to tighten them down. You've got to be careful. You don't want the weight of the chuck to put any stress on that handle there, the shaft I should say. So I just got that gripped in there, and that worked real well. Just gave me enough leverage to pull that thing off smoothly and easily. But as I say, be careful not to twist this up or down or side to side, or you could bend your lead screw. Alright, with that off, and now we need to get this calibrated collar off. And the trick here is it sometimes can be pretty stiff, but there's a little flat spring under here. Well, it's flat, but it's also curved. You'll see what I mean when I get there, but that will tend to fly off into space. So you want to keep your fingers around this area here to capture that spring before it flies off under the lathe bench or somewhere. And so I'm just kind of working that off, and there's the little spring. So you got to be real careful not to lose that. If you do lose it, it's not real difficult. You can find some spring type material, and I can't remember offhand what I used. I guess some steel strapping like they use to strap the wooden packing crates that the lathe comes in sometimes. You can cut a little piece of that with some tin snips and make a replacement. I've done that before. And they're easy to lose, but I'll get it into my bag here and then I don't have to worry about it. So that spring, by the way, is just to apply some pressure on that calibrated dial so that it doesn't slip. You want it to turn with the handle, and so that just provides enough friction to make sure that dial turns with the handle. Alright, now we need a 3mm wrench, and a T-handle wrench works well if you have one. And you can just grip it down here and twist these two screws out, two socket head cap screws. And I don't really need to take them all the way out, because I just need to loosen them up enough so that we can adjust this a little bit. And here's what happens is when this is tightened up, because these holes are not real precise, you can see there's a tiny amount of play there. They're not quite tight right now, but you can see there's a few thousandths of play. And depending on their alignment, it can be enough to throw off the alignment between the lead screw and the nut. And by the way, the nut here is actually not a nut per se, but it's a female thread cut into the casting of the cross slide itself, or the compound I should say. So that all has to line up nicely in order to get a smooth turning action. And what I like to do now that I have this off of here, I'm going to loosen these, snug these up, and then just back them off a tiny bit so there's just a little bit of play in there. So it's almost tight, but not tight. Okay, now I want to put the handle back on, so I'm going to put this fat washer on here. And I'm going to leave off the calibrated collar and its little spring for now. And that will enable me to access these screws while the handle is in place. So there's our handle back in place, and now I need my lock washer and the screw that holds the handle in place. See if I can do that without dropping it. Okay, and then I'm going to take my 4mm wrench and snug that whole thing down there. So now I've got the handle back in place, but I've left off the calibrated collar so that I can get access to these two screws here and play around with this adjustment while manipulating the handle. Well, now I need to go back over here and snug down these screws again, because in order to get this part right, these screws I've got them slacked off too much right now and I won't be able to get a good feel. So I'm going to tighten these down until they snug up, back it off a 1/4 turn. Okay, loosen it, snug it down, back it off a 1/4 turn. And having a little trouble getting that in there. Okay, loosen it, snug it down, back off a 1/4 turn. Alright, now I'm hoping, okay, now it does move pretty smoothly, or better than it was. With the handle now in place, I can draw the compound out, and there's a little bit of wobble here because these are still loose. But in order to move the compound inward, I have to apply tension back here on this screw, because the other part of the assembly here is normally where the pressure comes from, but since that's missing, I have to hold that in manually in order to draw the screw inward. And what I'm going to do is draw this in until it's pretty much all the way in as far as it'll go, and then back it out just a little bit. And a lot of times that gets you as close to the thread as you can get, so sometimes that's all you need to do in order to line the lead screw up with the thread. So I'm going to try tightening this down now and see how that feels. Not too bad. So I think that probably did what we needed to do to get that lead screw lined up with the thread that's cut into the compound itself. So we'll go back now and reassemble this, and then go back to the procedure where we left off. So we need to unscrew this again and be careful not to lose that washer. Now this part can be a little tricky. There's this little flat or curved spring here, and you got to be real careful not to lose that. It's going to want to spring away to wherever it can escape to. And as you slide this collar, this calibrated collar in place, the way I like to do this is take a 3mm T-handle wrench and apply pressure to the spring to press it down, hold it in place, but also depress it so that it will go down into the slot and allow this collar to slide on. So if you don't do that, then that spring will prevent the thing from sliding back, and more than likely will fall out and get lost somewhere. So that's a trick that should help you with that. Alright, so we've got that, and we want to tighten this all the way down until that lock washer flattens out. Now if I left the part out there, because I still had it in the vise, and that's the washer that goes underneath the handle. I've got to take this back off again. Pop that out, and remember this washer we pulled off earlier using the vise. I'm now going to slide that back in place, and then I'm going to release the vise jaws and leave that where it stays, and now we'll put that handle back, and then we should be good to go. Alright, we've got it reassembled now, and it feels pretty good. So I'm going to resume my adjustment process, and since I've fooled around with the settings on these 3 Gibbs screws, I'm going to go back and kind of start at the beginning and back this one off, snug it down, back a 1/4 turn. Same thing here. Loosen the lock nut, snug it down, back off a 1/4 turn, tighten the screw, the lock nut, and same thing here. Alright, now we've got our starting point established, and it's feeling pretty smooth, so the little routine that we did there to align the lead screw seems to have worked. And now all we need to do is basically what we did, the same process that we followed for the cross slide. We repeat that same process for the compound, and it's just a matter of tightening it until we start to get drag, and then backing off just a little bit. So that center screw now, I'm feeling just a little drag there, so I'm going to leave that and go on to this other one. Now you probably want a little bit more drag on the compound than you normally would want on the cross slide, and there's 2 reasons for that. One is, while with the cross slide you're frequently moving it relatively long distances, which is to say 1 inch or more, 2 inches maybe, while you're doing, for example, a facing cut. The compound, unless you're actually cutting a beveled edge on a workpiece, typically is moved in smaller increments. And because of that, it's okay to keep it a little tighter, but also you don't want it to be moving around due to any vibration. And particularly if you're cutting threads using single point threading, the settings on this dial are fairly important, or fairly critical to getting your depth of thread to where you want it. So you don't want any looseness here that would cause this to change due to vibration. And because of that, I like to keep the compound a little bit tighter than I keep the cross slide. So in other words, a little bit more drag is desirable. Now you may find if you ever need to do a beveled cut that the extra drag may be an impediment. It makes it a little harder if you need to crank through the whole range of compound movement. But you should be able to find a compromise where it's not too bad. And the worst case is if you are cutting a bevel cut and you find it too tight, you can always just loosen it up a little bit for that job and then readjust it. So that's just about where I want it now. Let's see how it's running pretty well. And again, when you're tightening, particularly this screw here, you want to make sure that you're over top of the bottom part of the compound. If you tighten it while it's out here, it's going to tend to press that Gibbs strip in too far, and then as you move the compound forward, you'll find that there's excessive drag. Same thing for the one on the other end, so it's best to adjust them while they're in line with this bottom piece. So I'm going to pretty much declare this done. Well, that wraps up our procedure for adjusting the compound and cross-slide Gibbs. And I actually covered a little more than I intended in this video. I had not originally planned to show the lead screw adjusting process, but it came up during the course of our other refinements, and so I went ahead and included that in this video. But I do have some ideas for some future follow-up videos, and one of those would be using grinding compound on the dovetail surfaces. And the grinding compound will impart a fine and smooth finish, or much smoother than it is now, surface finish on the surfaces of the dovetails, and that causes a tighter fit, which has benefits of smoothness as well as further tightness in the whole assembly that reduces the tendency for any dig in of the tool or chatter. And last but not least, on the saddle itself, there are some adjustments that can tighten up or compensate either more or less for the spacing between the saddle and the ways. And if, just like the other adjustments, if those are too loose, there can be a tendency for the entire saddle to tilt, and it can tilt either front to back or up and down lengthwise on the ways if it's not tight enough, and cause all sorts of problems. So those rarely need to be adjusted, but it's good to know that there is an adjustment for that and how to go about it in case you need to do it. And so we'll talk about that in a future video, and if you're interested, keep an eye out for those. And I'd appreciate it if you subscribe, and then you'll get a notification when those come online. So until then, thanks for tuning in, and we'll see you next time.